All right, we're jumping into 8.2 here. The rest of chapter 8 is going to be new techniques and hopefully, not hopefully, but techniques that maybe you haven't quite seen before. So these should be fresh. So this first technique here, 8.2, we're going to be talking about integration by parts. This first video I'm going to make is just kind of the setup and the behind the scenes. I'm going to do this in Word because it's a lot to write out, and I know my handwriting's pretty bad. And I want to save my handwriting for when I'm actually working through examples. So before we get to examples, this is going to be about how it works and why it works. So first off, integration by parts is used whenever you're simplifying integrals of this form. Whenever you can split up your integral into two functions that are kind of multiplying together, f of x and g of x. If this is the case, then integration by parts can help out sometimes. Okay, so here's the setup and kind of the behind the scenes of how it works. And there's a lot to this. You're not going to be tested on this part of it, but I do think it's interesting and how this came about. Before we jump into just integrating over two functions that are multiplying together, let's look at the derivative of two functions that are multiplied together. This, you hopefully remember from Calc 1, is what we call the product rule for derivatives here. And there's a bunch of different ways of writing out the product rule. I have always remembered it as the derivative of the first times the second, that plus the first times the derivative of the second. So whatever you need to do to remember that. These can be interchanged. I know some people remember it the other way around, and it really doesn't matter. But it's just the derivative of the first one times the second plus the first times the derivative of the second. Okay, so that's from the past, from Calc 1. Now let's look at integrals. But instead of just integrating over two functions that are multiplied together, let's look at integrating over the derivative of two things that are multiplied together. The reason we're going to do that is that we have that fundamental theorem of calculus. Whenever you take the integral of a derivative, those two things just cancel each other out. But we're going to be a little bit more careful about it. So instead of just canceling it all out, let's substitute in the product rules derivative here. So instead of integrating over the derivative of two functions multiplied together, let's integrate over this right-hand side, derivative of the first times the second, plus the first times the derivative of the second. Okay, so now what we can do is we can kind of split up this integral into the two separate integrals. So just rewriting this as the integral of that first term up top, plus the integral of the second term. Okay. Then what we're going to do is we're going to rearrange this. Think of this as this first left-hand side here is equal to this side down here. I'm going to add and subtract some of these integrals and kind of rewrite this. I'm going to solve it for this last one right here. So I'm just going to write that one first. The integral of f of x, g prime of x dx. That's going to be equal to subtracting this over to the left-hand side. So we still have the integral. I'm not even going to write it as the integral anymore, right? Because remember this left-hand side, the integral and the derivative canceled out. This is just the two functions multiplied together. But that's going to be minus subtracting over this integral, the integral of the f prime of x, g of x dx. All right, this is what we need. This, believe it or not, is going to be our definition here for integration by parts. It's just that that's kind of ugly looking, and so we simplify it down a little bit. What we're going to do is we're going to set f of x equal to u, and we're going to set g of x equal to v. The reason we're going to do that is because that means that du is going to be the derivative of f of x dx, and then dv is just going to be the derivative of g of x dx, those differentials that we always get. So you can kind of think of integration by parts as doing two u substitutions, substituting in a new function u and a new function v into our integral. If we rewrite it this way, maybe this is something that you have seen before, we get this. The integral of u dv is equal to, and this is the part that you need to remember, uv minus the integral of v du. Okay, so this is our formal definition now for integration by parts. If you have this integral and you can rewrite it as a u and a dv, two things multiplied together, this is going to be your antiderivative, uv minus v du. Just one more thing I want to say in this video before we get to some examples in the next video. You always want to choose your u to be something that is easily differentiable. And then that means that your dv is chosen to be something easily anti-differentiable. Sorry, I was reading my notes as I was typing and I got confused there. So choose your u to be something that's easily differentiable and choose your dv to be something easily anti-differentiable. And not just so that it's easy, but that it starts disappearing. You want to choose your u to be something that when you do take the derivative of it, it starts to break down and go to zero. And you'll see what that means here when we do some examples. All right, so ending this video, and I'll do some examples here in the next video.